Okay, great. Welcome to this talk, which is called Eco-Friendly ML. By the way, my dad and I used to sail. We would probably never take the boat out in that kind of swell there, so I don't know if anyone else has noticed that. This is a community talk, like a lot of the other talks in this venue. So if you're coming for deep detail on Kubeflow, we have lots of other great talks. Michelle here and Amy had a great one yesterday, and we're going to have birds of a feather later on. But this is a community talk, so it's going to be very light on details, and we're going to basically talk about, in general, the machine learning DevOps problem space. And with respect to Kubeflow, what the project goals and aspirations, the original ones and what they continue to be, and then how the community and projects started to come together, basically, how the pieces started to fall into place. And towards the end, we'll talk about, in general, how good open source works, what makes a good community. We feel Kubeflow is a good community, and we'll talk about some of the attributes of that community that we think are good. So, you may have seen this in maybe some of the other Kubeflow discussions. Sort of the starting point is that today it's pretty difficult to do big machine learning when you think of all the different types of components and pieces that go into a machine learning workflow and pipeline. You have your data ingestion, data analysis, you gotta do feature extraction, you have data scientists working with notebooks, and they're putting together models. Those models need to be deployed and served. And in some cases, maybe you're reliant on GPUs for parallel processing. There's lots of different factors that come into play when you're dealing with the pipeline for machine learning. So the concept here with the Kubeflow project and the community was to bring machine learning for everyone, basically. But as I mentioned, there's a lot of pieces that are required to be in place to have a comprehensive machine learning platform. And it's really difficult for one project or one institution to try and solve that. So with this project, the idea was to basically start with sort of a high-level mission statement. And some of the goals of that mission are to make it portable. So whatever we're building for this machine learning platform should be able to go from bare metal out to the cloud, scalable from one developer, one machine to hundreds, and it should be composable. And that's the modern microservice architecture. You should be able to take different pieces and have good separation of concerns and have those well integrated together. So guess what? Kubernetes, the conference we're at, checks all these boxes. It's an ideal platform for doing this sort of deployment or composition of a platform for machine learning. So that's sort of the obvious starting point. But beyond that, where do you go? So I don't know if Jeremy's here, but I made up this attribute for Jeremy, and I doubt that he actually ever said this. But the reason I have it there is to illustrate this point. And if some of you were in Craig's previous talk just before, there's always this notion in open source and projects about velocity versus adoption and the sort of tension between the two. So ideally, you're trying to strike a balance, I think, between those. You're trying to have good velocity, but also be comprehensive, good breadth in terms of this, this project that you're putting together. So just like Jerry Maguire, we start with sort of a more specific mission statement. And the Kubeflow mission is dedicated to making deployments of machine learning workflows on Kubernetes simple, portable, and scalable. Okay? Now, that second point is really important. We're not trying to reinvent the wheel. There's lots of good machine learning frameworks that already exist. So TensorFlow, scikit-learn, PyTorch, The goal of this project is not to reinvent some of those types of projects and try and improve on what they're doing. It's more to integrate the best of breed of these open source projects and incorporate them into a comprehensive machine learning framework. So, and then finally, anywhere you can run Kubernetes, ideally you should be able to run Kubeflow, okay? So that was sort of the overall mission statement. Great, but there's still lots of questions and issues. So how do we run our data science notebooks? What about the data pipelines that we need and the data provenance in terms of, you know, what actually produced this model? What were the inputs and what outputs do we have? In terms of the notebooks themselves, what about access, ingress control? And if we're building this platform, we need continuous integration and continuous deployment. So there's inference, deployment into different environments. There's still lots of questions. So with the Kubeflow project, it became a matter of sort of going around and looking at what was out there. Okay, what are the components that we could start piecing together to sort of bring this project into reality? So where to start? And you know, Craig previously talked a lot about sort of this notion with open source. Open is key in terms of discussion. So when you go to blogs or forums or conferences like this, there's a lot of good discussion, and that's an obvious starting point. So when you're trying to build something like Kubeflow, the idea is to maybe reach out to other communities, see what they're working on. Do their goals align with your goals? Do they have a feature set that can actually help you solve a problem? So that's a good starting point. What happens after that? It's best to actually start participating in these communities, okay? So the best of these communities have Slack channels, or they're on Gitter. Maybe some are still on IRC. But the idea is to get involved in those communities in the discussion, ask questions, and then in the GitHub vein itself, or GitLab, you can raise issues and you can offer pull requests. And that's a great starting point for the integration of these projects. Start by a position of maybe helping that project achieve their goals with the goal of reciprocity back to your project. So early on the Kubeflow project, we had a fair amount of interest and some enthusiastic collaborators. But one point I wanted to make is it's really important when you're interacting with these projects. There's typically a main line of development, you know, the master, and it's important that that's kept pure, right? And that's how most communities sort of run their code development and CI and CD. So sometimes you have an enthusiastic contributor who gets sort of tripped up by the notion of rebasing and squashing commits and things like that. So this happened a couple of times in the Kubeflow project early on, and we, as a community, exercised a great deal of patience in trying to help that individual along, because what they were offering was valuable. Their interest, their enthusiasm, and then finally, you know, what they were trying to implement. But, you know, you've got to work around some of the issues if there's sort of a lack of understanding of some of these concepts with Git and other SCMs. So, and an obvious one that we probably all know about is GitHub makes it really easy to cross-reference issues across repos, across projects. So you can easily sort of start creating sort of this symbiotic sort of connection between your products by referencing issues in both places. And then finally there, in that section, you want to treat that community with the same respect and importance that you feel is deserved in your project. And so I think it's a good sort of stance to have, basically, when you're approaching an opportunity to integrate with another project. So some of that is prescriptive, what I've just described. Now I'll fall back into sort of the retrospective part of this. And so with the Kubeflow project, we talk about this platform that we need for machine learning. And we wanted to have integration with all these other different projects, but we need an on-ramp. We need a point of integration to bring these other projects into the fold. And the Ksonnet project turned out to represent sort of that on-ramp. So Kubeflow uses Ksonnet. It's a JSON-based tool, basically, to generate these Kubernetes deployment objects. So you express them basically in JSON. They have primitives, basically, for things like pods and services and CRDs. And with that, you can write sort of very descriptive and powerful mechanisms for integration with the components. Okay? Now, what you get once you use Ksonnet to deploy these resources is what you would generally recognize from Kubernetes in terms of YAML or JSON for the resource objects. The other powerful part of Ksonnet is that because you can have parameters for the components, you can basically have different settings for different environments. Perhaps you have a dev environment or a test environment, staging, prod. You can have different tweaks for your components that are used to push the deployment of Kubeflow into that environment, okay? And also continuous deployment. So when you make your changes, you set up your parameters and do an apply, you're basically getting a regeneration of your Kubeflow deployment. And by that same token, you can actually tear it down with Ksonnet as well. So you can have a deletion of the resources there. Ingress, that was one of the other questions, and one of the projects we attached to or integrated with early on was Ambassador. So that's a cloud-native ingress controller, and it's based on the very popular Envoy project. We could do ingress in JupyterHub itself. We'll talk a little bit more about JupyterHub in a second, but this is cloud-native in terms of it's designed to run in Kubernetes environments. So it was a natural fit for what we were trying to do. And as a reverse proxy, we could easily annotate the services with the different URLs that we needed. And it integrates well with the identity-aware proxy for GCP, and also it can integrate with Cert Manager. In terms of CI/CD, there's the Argo project, which perhaps you've been to some of their talks at this conference. And it's a native, again, this is a theme with all these integrations that we have. It's cloud native, Kubernetes native workflow manager, so a CRD and an operator. So that's an important piece in the Kubeflow project. It's the underpinning for our pre and post submit testing. It actually exercises end-to-end test workflows for each commit that is going into Kubeflow. It also is involved or part of the KubeBench sub-project that was donated by Cisco, and also the Kubeflow pipeline sub-project makes use of Argo as well. So basically you define your workflows in YAML, and then you activate them, and what you're building up is basically a DAG, a directed graph of these workflows to basically do things, in the case of our pre and post submit testing, standing up environments and basically exercising tests. So in general, it's also really good for just doing machine learning pipelines. You can stitch together things for jobs for doing machine learning or data processing and basically putting together pipelines. Seldon was one of the earliest components that got integrated into Kubeflow. And that's a project that deals with running inference graphs, deploying and manage them at scale on Kubernetes. So these graphs are basically deployed as microservices, and they have different types of graphs that can be stitched together, basically. So you have different components that each run as a microservice, model, transformer, router, and they support a lot of the different popular machine learning libraries like TensorFlow and scikit-learn. And you can basically mix and match those components in various ways. It has gRPC and REST interfaces, And basically it uses OpenShift S2I to generate these model wrappers that get deployed into the graphs that are run for inference. And one of the other early projects that got involved or we integrated with Kubeflow is Pachyderm, and I was just talking to Nick Harvey right here up front. I guess you guys sort of describe it as Git for data science. I think that still applies there. So the idea is to have reproducible experiments, and you construct data science pipelines, and there's a specification in JSON for expressing the transformation and the degree of parallelism and the types of inputs. And you guys, for the open source version of your product, you have a CLI. I know you also have a UI in the enterprise project. So, and Ericto, and Vangelis is there. There you go. This is another project and community that has done a lot with Kubeflow. And one of the biggest things they've introduced is updates to our Jupyter UI. So we had sort of a sort of bare bones UI to begin with when we first started developing the project. And Vangelis and his team has done amazing work in sort of bringing in some updates that will basically land in the next release, which is 0.4. So you'll be able to talk to these people more about their projects after the talk. But basically, you guys do data management that is tightly coupled into Kubeflow, and you make use of PVCs and PVs for that. And then there's the notebook side of things with Kubeflow. So, of course, we had lots of conversations with the JupyterHub project early on. And they have a feature called the Kube Spawner, which is what we use to basically launch our notebooks as pods. And there's been sort of ongoing conversations and dialogues about things that we feel we need to customize, or perhaps things that maybe they're working on. So again, it's a very sort of open conversation between the two projects, trying to arrive at things that basically serve both projects, both Kubeflow and JupyterHub. In the project, we actually curate our own CPU and GPU notebooks, and we currently make use of the default builds for the notebooks. Now, these days, there's companies like Intel, and at Red Hat, we are generating some wheel files, basically, that have different optimizations that you can turn on for TensorFlow. With respect to the Kubeflow project, we use the default ones that are produced by the TensorFlow project. We've also worked with the team at Kaggle. They have a Python notebook, and we've basically adopted and adapted that to run within Kubeflow natively. So that's kind of different from our curated notebooks. They have a lot more content in the Kaggle notebook. It makes for a much larger image size, but it's still a very powerful tool for basically having a whole plethora of different machine learning libraries and visualization libraries at your disposal. And we've also been working with the Rapids AI project from NVIDIA. They also have a notebook image, and we've been adapting that into Kubeflow as well. So there's been some give and take, some back and forth with that team about the adaptation, and some things that we noticed that result in basically issues against their project, but it's going really well. And so that's sort of the technical side of things, everything I mentioned up to there. In terms of the Kubeflow project itself, sort of on the non-technical side, we have very good project governance. So we have a code of conduct, And that code of conduct is very much in line with CNCF. So it's designed to make sure that the project is basically a harassment-free experience for everyone who's involved. So it's a very open and welcome community, and it basically offers a high degree of participation. So part of that work is to set standards in place for a healthy and positive community. So the use of welcoming and inclusive language, respectful of differing viewpoints, the give and take of constructive criticism. And basically, everything should be oriented around focusing on what's best for the community. So also, as part of that, we have conflict resolution protocols. If there's a contributor or some other project member who wants to raise an issue with regards to project governance, we've laid out very clearly the steps that they should take to raise awareness about their concern. So this is what we do in the Kubeflow project, and we hope to see it from the other projects and communities that we interact with. So today the community, it's on GitHub, it's ASL2, 23 repositories, 135 contributors in the core project, in the core repo. And as I wrote this, there was about 909 commits in that core repo. So we're just releasing 0.3.4, and we are getting ready to release 0.4.0. So we're having these integrations that are continuously happening, so it's, this sort of, as a community, we're trying to keep up with the tremendous amount of interest and enthusiasm that people have shown for the project. And we've had a lot of institutional participation. I'm not meaning to leave anyone out there. I apologize right now if anyone feels slighted. These are some of the companies and organizations that have been actively involved and provided valuable contributions. Which brings us to the power of open source. So these communities work, and Kubeflow works because it is the sum of its parts and its people. So it's a great community. I've been involved with it since the early part of this year, and it's been very fun to be involved with. It's fairly young. It's often been said that it was just a year ago that Kubeflow was announced. So here we are a year later, and we've made great strides, but there's still a lot more work to be done. Love to see some more participation and contributions from people. I'd love to hear more about your use cases. But the idea here is that when we interact with your community and your community interacts with ours, everybody wins. It's a win all around. So there's free exchange of concepts and code, and it works to really promote each other's projects and communities. So there's a real multiplier effect that is in effect for the respective community's user base. We can all sort of build off that. So, and I think for the contributors, certainly I feel this way, is that there's a sense of empowerment. Many of us have had day jobs where we're not involved in open source, and sometimes it can be a slog. It's different with open source. You have a lot of people who are interested in the work you're doing, and they're supportive of the work you're doing, and we all sort of celebrate each other's victories, as it were, and contributions. And that's it. I don't know how I'm doing for time, but that's a whirlwind trip through the Kubeflow community. So a few minutes for questions, if anyone has any questions. Yeah. The question is when the 0.4 release might happen. Michelle, what is our current timeline? Or Abhishek? Or Jeremy, there you are. I'm sorry? So we'll start cutting release candidates next week, and then a release in January for 0.4. Yep. We good? Okay, one reminder, right after this is the Kubeflow Birds of a Feather. I don't know if it's right after, but it's 3:40, I think it starts. And is it 6:18, 6:20 might be the rooms? Yep. And we'd love to see you all there. We'd love to hear your experiences if you're a Kubeflow user. Love to have your feedback, ideas for contributions, definitely use cases. So come along and join us, and we'd love to meet you there. Okay, thank you.